So in our last video, we worked through questions 1 through 10 on the Unit 1 practice problem set. So let's pick up with number 11 right here. And the question says, consider the following table. And so we've got a table with two rows, and the first row is associated with the variable r, and the second row is associated with the variable s. And our questions are about functions and whether we're looking at, basically this is about the definition of a function. So part A, is r a function of s, and if so, what is the function's domain? So if r is a function of s, if that is a legal function, that means that, first of all, notice that this is reversing. I think our natural intuition is to think that this is going to be the input and this will be the output to go this way, down. But actually we've kind of flipped the order here, and we're saying that if r is a function of s, s is going to be the input and r is going to be the output. So we're actually moving in that direction. And in the sense that, I mean, we put in an s and we get out an r. So if that's going to work, if that's going to be a function, then we have to satisfy that each input has a unique output. And so if these are the inputs, if the s's are the inputs, do we have any repeated s values that go to different r values? And as I look through the s values, I don't see any repeats. So there's only one instance of each of these numbers, right? -3, -1, 0, 2, 4, and 6. So I don't have any repeats in the s row. So therefore, that alone is enough to tell me that yes, this is a function. So r is a function of s. So that means we want to know what the domain is. So the domain is going to be these numbers, and this is a discrete set, so we have to use curly brackets. This is not an interval. This is just disconnected points on the number line, and we just have to list all of these: -3, -1, 0, 2, 4, and 6. So that would be my domain. Okay. For part B, so that's part A. For part B, is s a function of r? That's the more traditional order of things, where and by traditional I mean this would be the input and this would be the output. And so our arrow now will be going that way. Now, in this case, I see a problem because I have a 2 here and I have a 2 here. So this is basically saying s of 2 is equal to -3, but it's also saying that s of 2 is equal to 2, and that is not good. That is that violates the definition of a function. So no, this is not a function. So s is not a function of r, therefore the question about the function's domain is moot. We don't even have to answer it. All right, let's move on to question 12. This is a word problem, and it says 6 miles west of town, oil-bearing deposits are found 3,176 feet deep. Also, 8 miles west of town, oil is found 3,328 feet down. Assume the oil-bearing stratum lies in a straight line. Part A, find a model that gives the stratum's depth d in feet as a function of x, the number of miles west of town. And then part B is about using that model. So let's focus on part A, and then we can worry about using it after we have the model. I think it's always a good idea to sketch a rough graph just to get your bearings. So the horizontal axis in this case is going to represent function of x, the number of miles west of town. So this is number of miles west. And the vertical axis is the stratum depth, or the oil depth. in feet. And now I can plot my points, because that's actually what I have here, is I'm given 2 points. Notice that you're not given like a slope, you're given a 6 miles and a depth, and then 8 miles and a depth, and those are 2 points. So if you wanted to think about this like a table, we could certainly do so. And my first column could be my miles, and then this could be my depth. So at 6 we're at 3176, and at 8 we are at 3328. So I can mark a point here and I can mark a point here, and that one will be 3176. This is going to be a little bit crunched for space, and then this one will be 3328. Okay, so if we're going to assume that this stratum is in a straight line, then basically we want to come up with the line connecting these 2 points. Okay, so we want to find the line, the equation of the line passing through these 2 points, and there you can do this in more than one way. Notice that I kind of already put this in a table format, so I could use linear regression here, and that's probably the fastest way to do it. So let me show you how to do this using linear regression. Actually, I'll show you how to do it both ways, okay? But I'll do linear regression first. So if we're going to, and this only works because we're given 2 points. If I'd been given a point and a slope, then this would be more difficult. But since we're given 2 points, let me clear this. It's kind of easy to put it in linear regression form. I'm going to go ahead and clear my lists just in case. Okay. So list 1 will just be 6 and 8. And list 2 is 3176 and 3328. Okay. And then we want to do linear regression with that data. So you go to stat, calc, number 4 is linreg. Oops, and I'm sorry, I meant to actually, this is the line, but I didn't quite do it the right way. Let me do that one more time. Stat, calc, number 4, and then here I want to do second L1, comma, second L2, comma, vars, yvars, function, y1. That's so that it'll save the function as y1. And now if I go to my y equals, it'll be there under y1. But my function, I now know, let me bring that back, is 76x plus 2720. Okay, so that's my model. And that's the linear regression method. If you're not going to use linear regression, I think I'm going to have to bring up my whiteboard to do that. If you're not going to do linear regression, then you're going to have to use the point slope form of the line, because we're given these 2 points. I'll just sketch this real quick. This was the point 6 something, and this was the point 8 something, 3000 and whatever it was. I'll have to look back on the other screen. But then from these 2 points we can get the slope, and then use point slope, which is y equals m x minus x1 plus y1. So that's the formula way to do it. And then the point values were 3176 and 3328. So we would calculate the slope here. That's my slope. And then with it, whatever this is, which actually I know what it is, it's going to be 76 because we found it already when we did the regression, right? That's the slope, 76x. So that'll be 76. And then we would go to our point slope form and we would plug all this in. And for x1, y1, I can use the point 6, what is that, 3176. That'll be my x1, y1. And so our line would be y equals 76x minus 6 plus 3176. And that is also acceptable. So either form, either this or this works, okay? They're actually the same. If you simplify this line, you will get the version that I have in the calculator. You just distribute 76 through here and then combine the constant terms. So that would, oops, sorry, I didn't mean to do that. That would be, let me bring my calculator up, just so you believe me. Where did that go? Okay. 76 times, too much going on here, 76 times 6, and then that's negative of that answer, plus 3176 is 2720. So this simplifies to be plus 2720, which is the same thing that we got via linear regression. Okay, so, and that is not what I meant to bring up. Let me clear that. So we're ready to go on to part B. How far west of town should we drill to find oil at a depth of 3,700 feet? That is a type 2 question, meaning that we have an output and we are looking for an input. So 3,700, my graph isn't big enough actually. Let me go to the whiteboard and I can draw it on there. 3,700 is like up here somewhere. And so I'm trying to find that intersection point right there. So this is going to be a calc intersect question. So I will go to my function plotter and I'm going to type in 3,700 and I want to know when y1 intersects y2. So we could go to the table and check this out. I forgot what I had my table. Alright, let's start at 0 and then let's go to the table and look for the intersection to give me a x min and max. So not too far out, and there it is. It happens sometime between 12 and 13. So we will go for our window. 0 to 15 is okay. And then let's do zoom fit. And that's hanging up for some reason. There we go. Okay. So there's our intersection. And we'll go to second calc, number 5, intersect, first curve, second curve, and then my guess. I'm just moving my cursor over to where the intersection is, and then make sure you press enter a third time, and there it is, 12.894. 12.894. Excuse me. Okay, so 12.894. This doesn't specify a level of rounding, but if we were going to go to 2 digits, it'd be 12.89 miles. Okay. So I think that's all for this video. Then we will return and continue.